We understood the phrase derivative differentiation. How exactly do we find a derivative of a function? One of the method is your first principle of derivative. How does it work? First thing is, what is it? It's a formula to find the derivative of a function. Very clear. So we are looking at it to be a formula. So what is the basic idea of the formula itself? We're going to find the slope of a line connecting two neighboring points on a graph which are very, very close. Basically, we are finding the tangents. So using the idea of slope and taking 2 points which are very, very close. Okay, let me explain this with a graph. I have 2 points which are not that neighboring. They're not at all close. So there's a question which will help us understand the formula better. So you guys should answer this question. Very simple question. If I want these 2 points to be close to each other, the gap should reduce or increase? It's a very simple question. Yes, please do answer. They should reduce, right? So they should reduce to an extent. We'll see that. To what extent? This is not a good graph. This is not a good tangent. This is not a good tangent. This is not. It's better, best. This looks promising. So what happened over here? The gap between the points, it reduced. To an extent, they are almost overlapping. Remember, they are almost overlapping. Not exactly overlapping, they are almost overlapping. Which concept talks about this? Reducing the gap between two things. Limits. So basically, we are finding the slope of a line with the help of limits. We're finding the tangent at a point using the idea of slope and limits. Okay, so I'll show the formula. So derivative of a function, say f of x, is, it's going to look something like this, f dash of x. So we have the slope formula in this manner, divided by change along the change along the x, and limit comes over here. Now the question is, how do we get it? So before that, I would like to, I'll do that later. So let's look at how to derive this particular formula, the proof. So we are considering a function f, say we move something like this. That's a graph of the function. It's a real valued function. That is output our real number. So that's your f of x, and that's your x. And a be a point in its domain of definition. So we have a point A, say over here, that point is A. And let point P, so which is a comma f of a. So this is your f of a. So basically this is f of a. And this point is P, I guess I'll write it over here itself, a comma f of a, and Q a plus h. So if I consider a line, and the gap between this 2 points represented by this line is h. So basically this point will be what? If this is a and this is h, this would be a plus h, and corresponding y component is your point q, and this is your f of a plus h, and this would be a comma a plus h comma, I'm just writing the coordinates, nothing else, f of a plus h. Is this correct? Now the slope of this line will look like this. This looks almost like the tangent of the line at the point P. So what should I do? First, let me write the slope formula, and let's think about what to do next. Slope of PQ, let's write this first. Since we are deriving, we'll take step at a time. So slope is given by change along the x, change along the y by change along the x, and then we have f of a plus h. That's the change, right? That's the change that we're looking for. minus f of a, and this entire thing divided by the gap along the x-axis a plus h minus a. A bit of simplification and we have this. Here what happens? We have a minus a and a getting cancelled and we have h. But the thing is, we need to reduce the gap. That's our gap. This is our h in our case in this graph. You want to make it as close as possible. In mathematics, since we want to make this as close as possible, what helps us? What helps us? Since the gap between P and Q has to reduce, or they have to get very close. This tells that the length h has to tend towards 0. That's the answer I was looking for. It has to get as close as possible. I have an example over here. A similar graph. I think it's the same thing. So now the gap is huge. And the point that we are concerned with is point number 3. So what should I do? So look at the value. The dot on the right is getting closer and closer to 3, is it not? So the gap has to reduce. That is, the gap between the point, that is the length h, has to keep on decreasing, is it not? It's very important for you guys to understand this. So the emphasis. And finally, I think I'll be able to write it here itself. The tangent at P, we can find it with the help of limit f of a plus h minus f of a divided by h as h tends towards 0. So that's how we get the formula. Okay guys. So let me look at the formula again over here. So this represents getting very close. This is your gap between the points along x-axis, and that's your change along the y-axis. So let me kind of that would be better, is it not? So this is your change along the y-axis. So that's the funda. Okay guys, so using this we will derive quite a few things.